All right, guys, let's get started. Let's not waste time. If you got your videos, turn them on. If you got videos, turn them on. Let me see you guys. It's so much easier to teach when I can see your faces. How's everybody doing? You guys coronavirus free? You coronavirus free right now? Can you hear me? Can you hear me or not? Can you hear me now? Can you hear me now? Can you? Okay. I don't know what happened. Crazy thing. Okay. Let me see your faces as much as I can. I want to see your faces. I cannot wait until October 5th. What happens on October 5th? What happens on October 5th?
Come back.
We're live. We're live back here in the classroom. We're live back here in the classroom. I have a small hope that on Fridays, they're going to find me a room that's big enough for all of us to be in. I'm hoping that they're going to find me a 70 capacity room so that you guys can be physically in the classroom 2 days out of the 3 days. 2 days out of the 3 days. Guys, I'm going to try my best to keep Zoom going on the other days. So you can be in class virtually on those other days when you're an A day, Z day team. Also, I'll keep videoing. I'll keep videoing so that you guys have that also. A reminder that WebAssign 3, and those watching the video, is due on Friday. WebAssign 3 is due on Friday. It's over continuity. It's over continuity. WebAssign 3 is due on Friday. I don't know if we're going to have a quest next week or not. I haven't decided on that. If we will have a quest next week, it'll be next Friday. I'll let you know this Friday if we actually have a quest next Friday or not. I may wait until we're back in person. But I don't want to wait too long. I guess the first thing I want you guys to do is stand up, stand up, stand up. You've been sitting long enough. Stand up, stretch, stretch. Oh, okay, sit back down. Calculus is about 3 things. What are those 3 things?
Limits, derivatives, and integrals.
Oh my. Limits, derivatives, and integrals. Oh my. Okay, we've been talking a lot about limits, and today we're finally ready. You finally have enough machinery with your limit tools for us to start taking on the derivative. So this is the definition. Of what it means to be differentiable. And we're going to fill in, but I want you to just copy that down. Just copy it down. I'll read it. Okay. The function f is differentiable at the point x equals c if and only if the limit as x approaches c of the numerator f of x minus f of c, the denominator x minus c, if this limit exists. And I know you guys are behind, you're copying. I'll go over it again. And we denote the value of this limit, the one that it goes to, as the symbol f prime of c. The symbol f prime of c. So I'm going to let you get caught up. And then I'm going to finish the rest of this definition of the derivative.
Dr. Warren, what is the word right after the function?
Right there
Down.
is.
It exists.
No, I mean the one below, does that say exists?
Exists, yes, sorry. E-X-I-S-T-S, exists. Okay, I'll read where we're at again. The function f is differentiable, D-I-F-F-E-R-E-N-T-I-A-B-L-E, at x equals c. And this is if and only if the limit as x approaches c of f of x minus f of c over x minus c exists. And we denote the value of the limit, we denote the value the limit goes to as this symbol f prime of c. This symbol f prime of c. It's just a symbol, f prime of c. Now I'm going to finish it down here and call f prime of c the derivative, D-E-R-I-V-A-T-I-V-E, of f at c. And I'll repeat that again. And call f prime of c the derivative of f at c. Okay, little choir, put your hands on the space bars, hands on the space bars, hands on the space bars, hand on the space bar. You guys are all going to say this with me. Are you ready? The function f is differentiable at x equals c. Stop. So we have a c value, we have a number, and we're saying the function, we have a function and we have a number. And what we're saying is the function f is differentiable at that number, at x equals that number. Good. Now let's go back, choir, to reading. Let's go back to reading. This part isn't hard. What's this part? If and only if. Now it gets complicated. The
limit as x approaches c of f of x minus f of c over x minus c.
And what is that word? What is that?
Exists.
Exists. So we've got this limit. We've got this limit that's defining our derivative. Notice there's a troublemaker. There's a Gary Dreibelbis in this limit. There's a Gary Dreibelbis, the kid you don't want to give a baseball bat to. She's going to attack the gym teacher with the baseball bat. I told you about that story, right? Okay, so notice we've got this x minus c in the denominator, but where's the limit going? Where's the limit going? X is going to c. That's going to cause what in that denominator? That's going to cause what in that denominator? If x is going to c, and you've got x minus c, what's that denominator going to?
0.
0. Is that a problem in mathematics? Is that a problem in mathematics? And you're like, yeah, that's a problem. Okay, if the numerator didn't go to 0, what could you immediately say about the limit? If the numerator didn't go to 0, what could you immediately say about that limit? Does not exist by our do not exist tool. But let's just look at the numerator. As x goes to c, f of c is just a number, but as x goes to c, f of x is also going to go to f of c. As x goes to c, that's going to go to c, and I'm going to be left with an f of c minus an f of c, which would also be the number, 0. So it's a 0 over 0 limit. It's a 0 over 0 limit. When we have a 0 over 0 limit, what's typically our next move? When you have a 0 over 0, I'm getting ready for quest 2. When you have a 0 over 0 limit with real functions, what's typically your next move, guys? Algebra. Factor. Simplify. Hope the Gary Dreibelbis goes away. Hope the Gary Dreibelbis goes away. If the limit goes to a number, that's all that exists means. A derivative is a number. Say that.
A derivative
Is a number.
A derivative at C is a number. Say that.
A derivative
at C is a number.
Okay, if this goes to a number, we give a symbol for that number. Now you're like, okay, Dr. Warren, I mean, like, seriously, we've got to come up with a new symbol? And the answer is yes, you're going to want symbols for this. You're going to want symbols for derivatives. Trust me. If we didn't have symbols, this would be a nightmare. As the function changes, this number's going to change. As C changes, this number's going to change. So we say, okay, we'll keep the function. We'll have f there, because we know it's going to depend on f. And we're going to have C there, and we know it's going to depend on C. Well, we don't want to use f of C because we already know what that means. This means plug C into the function. So the next easiest, the next simplest thing we can write down is to put a, oh, holy hell, I'm losing my brain. What is that thing called? What's English people? What's it? Apostrophe. The next easiest thing we can do is just put an apostrophe there so that we don't get confused thinking this means function evaluation. This is the, say this, the derivative.
Derivative.
Good. Of f at C. So this is the derivative of f at C. Say it again. Say it again.
This is the derivative of f at C.
Perfect. Perfect. Okay. The derivative at f. Oh shoot! I gotta land this. The derivative of f at C is a. Oh crap, Dr. Warren, I've already forgot. The derivative of f at C is a
Number.
very good, very good. A number. Whatever number this limit goes to, that's f prime of C. Whatever number this limit goes to, this 0 over 0 limit goes to, is the value f prime of C. Woo! Stand up again, stand up again, stand up again. Stretch again, stretch again, stretch again. Yeah, like this. Let's make snow angels. Let's make snow angels. It's going to be snowing before we know it. I think this is going to be a bad winter. I think this is going to be a bad winter. Who doesn't live in Harrisonburg? Who didn't grow up in Harrisonburg? Who didn't grow up in Harrisonburg? Okay. Who didn't grow up in the valley? Who didn't grow up in the valley? If you didn't grow up in the valley, raise your hand. Okay, sit back down. We have what I like to call, I grew up in Ohio, and we had bad snow. Okay, we had bad snow. We don't get that much snow here, but we can get what I'll call biblical snows. Biblical snows, okay? One time, I swear, one snowstorm, 34 inches of snow. 34 inches in one night snowstorm. I've never seen snow this deep. Then you're trying to get out, plow out, and then it'll be 50 degrees, and then it'll flood your basement. Then it'll be 50 degrees, and then it'll flood your basement. So yeah, you guys living in the bottom, you guys, anybody in a basement apartment, okay, if we get biblical snow, get your stuff up on things. Get your stuff up on things. Okay, but I'm hoping no biblical snow. Okay, Dr. Warren, ask me, is there a faster way of writing down the definition of the derivative?
Dr. Warren, is there a faster way The derivative.
Yeah, okay, try it again, guys, without yawning. Try it again without yawning. Try it again. Now, just try it again.
Dr. Warren, is there a faster way of writing the derivative?
Yeah, there is. Now, let me show you a faster way. Here's another way you can write it down. The definition, this is lazy man, DEF, parentheses N, definition of the derivative of f at c is that f prime of c equals the limit as x approaches c of f of x minus f of c over x minus c. Would you rather write down what I have? Would you rather write down what I have over here or what I have there for the definition? Would you rather write down this board or that board? This board or that board?
That board.
Yes. Notice all the elements are still there. All the elements are still there. We still have this symbol, f prime of c. We still have this 0 over 0 limit. We still have this 0 over 0 limit. Okay, we're ready to calculate a derivative. We're finally ready to calculate a derivative. So I need a c and I need a function. Give me a c, and don't say c. Give me a c. 3. Give me a function. Any function you guys want, and we're going to try to calculate the derivative of that function at 3. Give me a function.
2x minus 8.
2x minus 8. Okay. Let's calculate the derivative of 2x minus 8 at 3. Say what I just said. Say what I just said. Say what I just said.
Let's calculate the
Derivative of
the function
2x minus 8 at 3. Okay. So let's cast our play. Let's cast our play. Let's cast our play. We want f prime of c. Well, who the hell is c? 3. So we want to find the number f prime of 3. What's the value of f prime of 3? Okay, so let's, wherever you see a c, too many c's. Wherever you see a c in this, just put a 3 right now. Wherever you see a 3, just put a, so wherever you put a c, put a 3. Okay, so it would be, we would have the limit as x approaches 3 of f of x minus f of x minus f of 3, all divided by x minus 3. Okay, well, we've at least made some start. How many people can do that? How many people are pretty confident they could do that? Okay, now, here's your function. You guys picked it. Here's your function. You guys picked it. We need f of 3 in that numerator. So find f of 3. So at your seats, find f of 3. What's the value for f of 3? You guys picked the function. I didn't. You guys picked the function. Find the value f of 3. What's the numerical value, the range value for f of 3?
-2.
And hopefully everybody's pretty comfortable. Wherever you see an x, you're going to put a, wherever you see an x, you're going to put a 2. So it'd be 2 times 2 minus 8.
You need 3?
Thank you. I mean a 3. I need you guys. 2 times 3 minus 8, which would be -2. That number goes in right there. That number goes in right there. Don't write anything down. Don't write anything down. Write the limit as x approaches 3. Write the limit as x approaches 3. Draw that minus sign. It's the same minus sign as that. It's the same minus sign as that. Draw that minus sign. Now, what did we just find this number to be? What did we just find f of 3 to be?
-2.
-2. So put that there. Put -2 there. The Gary Dreibelbis is still there. We still have to deal with Gary. Say that.
We still have
to deal with Gary.
We still have to deal with Gary. Gary needs to go to detention. Say that.
Gary needs to go to detention.
I think Gary lived in detention. I think Gary spent all of his time in detention. Okay. Now, let's look at this. What did you guys pick f of x to be? What did you pick f of x to be?
2x minus b.
So let's put that in for f of x there. Let's put that in for f of x there. How many people are following? How many people are following so far? How many people are following so far? It's a new concept, so I want to make sure we're all kind of running together. Can you read this? 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 What does that say? What does that say?
0.
0 over 0. The derivative is inherently bad in that it has division by 0 in it. Most of the time you think it wouldn't exist because it's got division by 0 in it. But because the numerator also goes to 0, most of the time it does exist. Okay, now imagine you see this limit on your second quest. Imagine you see this limit on your second quest. If you plug 3 in the denominator, what do you get? You plug 3 in the denominator, what do you get?
0.
0. Plug 3 in the numerator. Plug 3 in the numerator, and what do you get? When you plug 3 in the numerator, what do you get?
0.
You also get 0. What's your next move when you've got a 0 over 0 limit? What's your next move when you have a 0 over 0 limit, guys?
Factor.
Factor, algebra. So have at it. Have at it. You pick the function. You pick the c. Have at it. See if you can't find out what number that goes to. See if you can't get rid of Gary. See if you can put Gary in detention. Can you put Gary in detention? All right. I'm gonna just for sake of time, I'm gonna grab the wheel. Okay. What is minus -2? What is minus -2? What is minus -2? Positive 2. Positive 2 plus -8. Positive 2 plus -8. You get a -6. So just doing a little bit of algebra. I'm there. Okay, is Gary in detention yet? Is Gary in detention? Is Gary in detention? No. You still have the problem with division by 0. Is there a way to factor and get an x minus 3 in the numerator? Is there a way to factor and get an x minus 3 in the numerator?
Yeah.
Yeah, so let's factor a 2 out. Let's factor a 2 out. And now I've got an x minus 3 over x minus 3. What limit tool can you guys use now? What limit tool can you use now? You guys, go to grid view, go to grid view, go to grid view, because I want you guys to see each other doing this, because it's too much fun. Okay, go to grid view, go to grid view. Now, do what you were doing, do what you were doing. Everybody was doing this. What are you doing? What are you doing? What are you doing? What are you doing? Slasher, slasher. So this would be the limit as x approaches 3 of 2 by slasher, by limit tool number 9. What's the limit of a constant? Do you have a limit tool that would allow you to take the limit of a constant? Do you have a limit tool that would allow you to take the limit of a constant? What's the limit as x approaches 3 of 2? What's the limit as x approaches 3 of 2? I think it's
the limit of x approaches 3.
Limit is the limit, we're right here. The limit as x approaches 3 of the number 2. What does that go to? In which limit tool did you use? What does that go to? We know we're slashing here. This is by slasher.
Is it limit tool 8?
The limit as x approaches c of k. The limit as x approaches c of k is k. Who's the c? Damn it, Dr. Warren. No. Who's the c?
3.
Who's the k?
2.
2. So this limit goes to the number 2. And we've done our first derivative. We've done our first derivative. F prime of 3, just follow the equals. F prime of 3 equal the number what? F prime of 3. The derivative of f at 3 is the number, the derivative of f at 3 is the number 2. We've calculated our first derivative. Now you're like, Dr. Warren, why? Why are we doing it? I'm not telling you. I'm not telling you right now. That's another day. You're going to calculate another derivative. Now this time I get to pick the function. This time I get to pick the function, and I get to pick the c, and you get to do all the work. Are you ready?
Yeah.
Thanks, Ferris. One person, one person. If you ask most kids what their favorite function was in high school, first of all, you're like, are you serious? Are you seriously going to ask me that question? What do you think most students' favorite function from high school is?
Is it a parabola?
It's a parabola. It's a parabola. And the simplest parabola is this function. F of x equals x squared. It's just a parabola that opens up, sits dead center on your xy coordinate system. Now I'm going to pick C to be the 7. I'm going to pick C to be 7. Now I want you guys to try to calculate f prime of 7. I'm going to push you to the top of the hill like a roller coaster, and then I'm going to let you have fun. I'm going to push you to the top of the hill like a roller coaster. I'm going to use the definition. I'm going to use the definition. F prime of 7. I know. Who's the C? Who's the C? I just got to get your brains going. Who's the C? Who's the C? 7. F prime of 7 is equal to the limit as x approaches 7 of f of x minus f of 7 over x minus 7. By definition, f prime of 7 is equal to a 0 over 0 limit. The limit as x approaches 7 of f of x minus f of 7 over x minus 7. You guys try to find f prime of 7. You try to find f prime of 7. You do the work instead of Dr. Warren. Try to find the number for f prime of 7.
Could you explain how you got -2 in the last problem?
Oh, it's not -2. It's positive 2 right here.
Oh no, right, but it's like f of 3 equals, and then it's like a chalk mark, and it's like.
Oh, okay, yes. So here's your function. Who's talking? I'm sorry. Who is that?
Trey.
Trey, man. So what I'm doing is I'm plugging 3 into the function, because I'm sure you're not the only one, Trey. And so when I put a 3 in here, I get 2 times 3, then minus the 8, and that's where the -2 is. I'm just trying to fill in that guy. I'm trying to fill in that guy. Great question, Trey. All right, ready or not, you're going into breakout groups. You're going into breakout groups, and you're going to share what you have with other people. You're going to share what you have with other people. You're going into breakout groups. Don't you dare quit my class. Don't you dare.
What, I got x plus 7.
Same. And then you plug in 7 for x and you get 14, right?
Yeah.
I got Dr. Warner.
Yeah, I had to join in. I thought Colin was in a room all by himself. I thought Colin, I was coming to save you, Colin, but you got good friends here. I'm leaving your room. Okay, okay. Now I just gotta ask. Did anybody get a number? Did anybody get a number? Did anybody find?
Dr. Warren, you're muted.
Oh,
I can't hear you.
Zoom's gonna kill me. Okay. Did anybody get a number? Did anybody get a number? Did anybody get a numerical value?
14.
14 is the answer. 14 is the answer. Were you able to get rid of Gary Divalbist? Were you able to get rid of Gary? Were you able to put him in detention?
Yes.
Who was Gary? Who was Gary?
X minus 7.
The X minus 7. That's the troublemaker. I also call him my brother Doug. Okay? All right, so let's just walk through the steps again, because I'm sure everybody didn't get 14. The first thing I want to do is get this value. I want to get that value right there. And this is what Trey was asking. He was like, Dr. Warren, how do you get, what are you doing? Well, I'm just going to take the 7 and I'm going to plug it in there. And I get f of 7 squared, and that's 49. And that's the number that's going to go into that location. There's nobody to deal with Gary right now, so I just leave it as x minus 7. This is 49. Now my functions change. I had 2x minus 8 or 2x, what that function was over there. Now my function's x squared. So in this location, I'm going to put the x squared. Now you'll know you've done it right if you end up with a 0 over 0. When you plug 7 into the denominator, what number do you get? When you plug 7 into the denominator, what number do you get? 0. When you plug 7 into the numerator, you also get a 0. What's the next move? What's the next move, guys? Almost all the time, what's the next move?
Factor.
Factor, algebra. Algebra and factor. So the denominator stays the same, but the numerator factors as the difference of 2 squares. Just factors into those 2 binomials. Now, what tool can you pick out? Slasher. And this would go to the limit as x approaches 7 of x plus 7. Is there any more division to worry about? Is there any more division by 0 to worry about? Is there any more division by 0? I'll keep asking. Is there any more division by 0 to worry about?
Nope.
No.
Okay. Is this a Frankenstein function? Is this a Frankenstein function? No. Do we have continuity? Do we have continuity? So unleash the continuity. Say that.
Unleash.
There's no more division. There's no more division. No possibility of division by 0. This is not a Frankenstein function. Release the continuity, which means you. Let's see if you remember your BFF. I don't even think you know your BFF. The BFF, what's your BFF? It's the limit as x approaches c of f of x equals continuity. Continuity. In your phone, you should have this picture. Continuity. The limit as x approaches c of f of x equals f of c. Let's see, what does it? Just plug it in. Just plug it in. So the moment there's no more division and it's not piecewise affine, we can evaluate the limit by just plugging 7 in to all the x locations. And 7 plus 7 is 14. 7 plus 7 is 14. You guys following? You guys following? Okay. We're gonna end class. We're gonna end class with a harder one. Like, I hate you, Dr. Warren. We're gonna end class with a harder one. This is my function. This is my function. Can you read the function? Can you read the function?
F of x equals x squared minus 2x plus 5.
And I want you to find the number for the derivative of f at 4. Find f prime of 4. What does f prime of 4 equal? Try to use the definition and try to figure out what you... This is a harder one. Again, it's x squared minus 2x plus 5. All right, you're going to breakout rooms. You're going to breakout rooms. You can share with each other. You can complain with each other what you have. You guys should be in breakout rooms too. I know, it's insane. I know, it's insane. So ADD, Paul. So ADD. Okay, does anybody have a numerical value for me? Does anybody have a numerical value for me? What number do you have? What number, did anybody find a number? What do you have?
6.
6. Now let's try to see, let's work through again. What was your first move? What was your first move?
Plug in 4 and Brad.
Okay, let's first of all get the limit. Let's first of all get the limit on the board. So it'd be the derivative is defined in terms of a limit. Say that. I wouldn't focus on it. The derivative is defined in terms of a limit. So it's the limit. Who's C? Who is the C in the problem? Who's clearly the C? 4. The limit as x approaches 4. What goes on the bottom? What's in the denominator? Who's the Gary Dreibel-Biss?
X minus 4.
Yeah, your x minus c. And then you got your f of x. That's part of the definition. Then minus your f of 4. Now, was it Brad? Brad, did you say plug 4 in? Is that what you said?
Yeah.
Brad says, okay, we want this guy. So we're going to plug 4 into my function. Now you guys help me out. When I plug a 4 in, what number am I going to get? When I plug a 4 in, what number am I going to get there?
16.
16 minus 8 plus 5. 16 minus 8 is 8. 8 plus 5, if I get $8 plus $5, I have $13. So I'll put my minus 13 there. I'll put my minus 13 there. Now, who was the function I gave you? Who was the function I released upon you? What was the function?
X squared minus 2x plus 5.
So let's put that there. X squared minus 2x plus 5. Is Gary still hanging around with a baseball bat? Is Gary still hanging around with a baseball bat? So we got to deal with Gary. We're going to get Gary in detention. All right. Now what is 5 minus 13? What is 5 minus 13?
Negative 8.
Negative 8. Okay, now I'm going to give you guys, I shouldn't tell you this because it's a huge hint. I should not tell you this because it is a huge hint. But because it's a 0 over 0 limit, because it is defined to be a 0 over 0 limit, one of the factors has to cancel out the x minus 4. So when you're factoring this, you know that one of the factors has to be x minus 4, which makes your life so much simpler. What would you need to get an x squared if one of the factors is already x minus 4? Well, x, you want a minus 8, but you got a minus 4. What does that one have to be? Plus 2. So that's just a little hint. That's just a little hint. As long as you've done this right, as long as you plugged the number in right, this guy will show up in the numerator. Now you're gonna slash. Now you're left with the limit. Now you're left with the limit as x approaches 4 of x plus 2. Is the division gone? Is the division gone? Is the division gone? Is this a Frankenstein function? Is this a Frankenstein function? Then I call out my big buddy continuity. I call out my big continuity, and how can I evaluate the limit? Just plug it in. Where I see the x, I put a 4, and I find that the derivative is 6. Okay. For homework, I've added new homework in section 2.6 and in section 3.1. Now listen, don't worry about the tangent line. Don't worry about the tangent line right now. Also, they'll ask you to take the derivative of the function. You're not ready for that. I want you in all of the homework to just find f prime of 4, just at one number, not for all values of x. So when it says take the derivative, I want you to find f prime of 4. We'll build up to the derivative function. Do you guys kind of understand what we're doing? Do you guys understand what we're doing? Okay, okay. Then I think I'm gonna call it because I'm not ready to start a new concept yet. So I'm not. You guys have a good day. Get outside. Get outside. It's too beautiful to be inside all day.
Thank you.
Have a good day.
Yes, sir.
Dr. Warren?
Yes.
I've got a quick question. If we do know how to take the derivative, should we take the derivative, or do you still want us to just find f?
On our quest, I'm going to force you to take it with the limit in at least one problem before we build all our machinery to take derivatives. So yeah, right now, just do it the limit way.
All right.
But Paris, we will get around to where, yeah, you'll be able, I'll let you use all the machinery we're going to create.
I have a question also about in-person versus online classes when we come back. When we come back, are we going to have to be in person, or do we have the option to be online?
I mean, that's a good question. I don't have the option. I have to teach in person. The university's saying that I have to teach in person. So I think students may have an option, but I don't have an option. So I'm going to keep making videos. I'm going to keep having my camera because I know some people will be in quarantine. You're not going to bring 2,000 students back and expect people not to be in quarantine.
But I was wondering how it would work.
Yeah, I mean, I think it's probably best to be in the class just because you can see the board and, you know, we can get into groups and, you know, it just works. I just think, and for me, it works better if I can hit the ball back and forth with you guys. We're doing okay. We're doing okay here, but it's so much easier where for you guys to not hand on the space bar, hand on the space bar. Go into groups and you're like popping into like who knows where and yeah.
Okay, thank you.
Thank you.
Thank you.
Oh, thanks, Brad. Have a good day.